Welcome intellectuals to our today's wonderful tutorial. So in this video we're going to revise on acceleration velocity as a function of time. So as we can see this question, the question reads, an object is vibrating at the end of a horizontal spring. If the equation for its position as a function of time is given by, you can see the equation here. Okay, so find the amplitude, frequency, period. That is question A. B, find the maximum magnitude of the velocity, acceleration. And 2, after 1 second has passed or has elapsed, what are the position, velocity, and acceleration? You can see this question has got a lot of marks. That's how it is asked in the exam. So we have the first one as 6, 6, 9, which is giving out how many? 6 and 6 giving 12, 12 plus 9 giving 20, 21 marks. Okay, though in an exam it can maybe have just 10 marks. That's how it can go up to those marks. So so a quick review on position, velocity, and acceleration as a function of time. I don't want to go direct, guys, to solve you this question. Okay, so what I'm going to show you guys is the formula for position as a function of time is given by x. Okay, is given by x as a function of time is given by a cosine wt. Okay, then the formula for velocity as a function of time. So where these equations are coming from, guys, I showed in the lesson where we fully understood. So guys, if you just want to become part of our tuitions, don't forget to WhatsApp me on this number. I'm going to tell you more about what we offer at the end of this lesson. Okay, so what about velocity? Velocity as a function of time is given. So these are the formula which you have to remember. So it's negative a w, then we have sine, we need to have sine wt. Okay, this is our equation 2. Then acceleration as a function of time, we have negative a, now w squared, then we have cosine wt. Okay, I explained very well where these equations were coming from using differentiation. So what you need to appreciate here is that you just need to know these equations. So a is an amplitude. A, you are seeing there showing an amplitude. Then what else? W just showing the angular frequency. And what else do we have? We have t showing just time. Okay, so x is position, and what else? V is just velocity, and a is acceleration. What else can I mention? Angular frequency is given by 2 pi f. Okay, 2 pi f, of which the frequency can be found. Now when we divide 2 pi everywhere, we are going to have the frequency, which is going to be equal to angular frequency over 2 pi. That means period is going to be equal to 2 pi over angular frequency, because period and the frequency are inverse of each other, so that we just flip the fraction. Then this can also be written as 2 pi over t. So other important thing which you have to talk about are maximum magnitudes. Maximum. How do we find the maximum velocity, which we call Vmax? Vmax is found by amplitude multiplied by angular frequency. Very important. Also, the Vmax, the Amax, is found by amplitude multiplied by angular frequency squared. You should take note of these equations. So this is a quick recap. Otherwise, you can take a screenshot of this screen so that you may be able to revise. So with this information, and you must be able to understand that you guys, all these questions, all these are going to be used to answer the question that we are going to that you have been given. So this is the question we have been given. We have been given the equation of our position as a function of time to be this. Then we are asked to find the amplitude, frequency, and the period. So here's the equation. The equation as a function of time has been given to be 0. It is 0.250. Let me check it. Okay, yes. Which is in meters. Then cosine, we have pi over 8 and multiplied by time. Sure, that's how the equation is. Okay, so the first question to be asked is to find the amplitude. So question A, question A1 is asking the amplitude. So here is how you find the amplitude. So when you use the formula for period, the formula for period, I mean for position as the function of time, is given by, I gave you guys amplitude cosine Wt. So you can see from looking that this 0.250 is just related to amplitude, then t with t, cosine with cosine, and w with pi over 8. That means we can even get to say that the amplitude is no other than 0.250 meters, and the angular frequency is pi over 8. Okay, so you can see the angular frequency is pi over 8. So the amplitude is 0.250 meters. Okay, so now our number 2 question is to find the frequency, then followed by the period. I said that the angular frequency is given by 2 pi f. Okay, so to solve for frequency, we say 2 pi over 2 pi. So you can cancel this. You have our frequency to be angular frequency over 2 pi. What do we get? I think I even gave you this formula. So the angular frequency is 8 pi over 8. So frequency is equal to pi over 8 over 2 pi. You have pi on your calculator, so just plant on your calculator. You are going to get the answer, which is going to be 0.0625 as, because this is in Hz, so that's how you find the frequency. Now, how do we find the period? How do you find the period? The period is very simple, so just use bro. I was saying that the period you can use that period is equal to 1 over frequency. So you just say 1 over the frequency, which we have found is 0.0625. So the period is going to be equal to 16 seconds once you find that on your calculator. Then B, what is our question B? Find the maximum velocity and acceleration. That is what I was talking about here when I was saying that the maximum velocity and acceleration. So B is asking about the maximum. Number A is asking about Vmax. I think Vmax is given by amplitude multiplied by angular frequency. So our Vmax will be no other than amplitude is 0 0.25 there multiplied by the angular frequency, which is pi over 8. So our Vmax will be no other than, so once you find this on your calculator, you are going to get the answer. It is going to be, once you round it off, is going to be 0.0982 meters per second. Okay, what about the Amax? These are very simple once you just know the question that I gave you. So the Amax, which is maximum acceleration, is given by angular frequency, amplitude, then angular frequency squared. So we're going to get our amplitude is just still the same there, right, by pi over 8 squared. So you get our Amax to be what? Our Amax is going to be 0.0385 meters per second squared. Okay, that's how we find the Amax. Okay, so now the last but not the least, what is going to happen after 1 second has elapsed? What is the position, velocity, and acceleration? So this is where this part comes in. Okay, and you can see what I'm trying to write here. Okay, so we are just going to use these three equations to find the position, velocity, and acceleration. Position, velocity, and acceleration. So what is going to be our position? You can see this position, we know this is our formula. So our position, question C. Okay, so after time has elapsed, which is 1 second has elapsed, what is going to happen to the position? So position at 1 second is going to be equal to, we have already been given this, so we just replace 0.25, then cosine pi over 8. So when you multiply by 1, we still have the same thing. So now my emphasis, when you are using these three equations, okay, when you're using these three equations, make sure your calculator is in Lagrange. So change your calculator from degrees to Lagrange. Make sure you change those settings. Hence, if you're not going to change that, you're going to be getting wrong answers. So when you're using these three equations, take note of this. Okay, so the position, so 0.25 cos pi over 8, we are going to get the position, which is going to be equal to 0.231 meters. What about the acceleration? What about the velocity? The velocity at time is equal to 1. You know the velocity is amplitude, negative amplitude then sine, must have negative amplitude, then W sine WT. Okay, so it's just the matter of us trying to replace all the necessary things. So our amplitude is still 0.25, negative 0.25. Then the angular frequency there is pi over 8. Then sine pi over 8 multiplied by 1. What do we get? As usual, velocity is going to be negative since we have the negative sign there. So the velocity is going to be equal to negative 0.0376 meters per second. How about the acceleration? Acceleration as a function of time is negative a w squared then cos wt. So I just replace time is 1, so amplitude is negative 0.25, angular frequency pi over 8 squared, then cosine is pi over 8. Even when we multiply by 1, we still have pi over 8 there. So acceleration as a function of time at t is equal to 1 is going to be equal to, negative 0.0356 meters per second square. So this is what you are going to get. So my main emphasis, guys, is here. So make sure you know these equations, and whenever you are using these equations, put your calculator in Lagrange. Only for these three equations. For the maximum velocity, use this. So to those that watch those long video lessons, I added on by telling you that the angular frequency is also given by k over m. So these formulas were transformed. These were replaced now by angular frequency. So I used to have that the Vmax is also given by positive or minus angular frequency, then k over m, where we also say that this is also same as just position. The amplitude becomes position when we are dealing with the mass spring system. So we talked more of this. So guys, guys, these things are very important. So you have to appreciate all the concept that has been given in the previous lessons which we handled. We've got a lot of questions to handle. So in the holiday, we learned all this. So as for now, we are just revising. So for you who missed all the lessons and you want to become part of our tuitions, just WhatsApp me on this number. Okay? Just 077636966. You WhatsApp me on this number so that you may be able to contact me, so that you may register under our tuitions. Apart from physics, we also do. So first we have physics, biology, maths, and chemistry. Make sure you register under our tuitions at only 70 kwacha per course. So once you register, you'll be able to access our live lessons. You'll be able to access solved past papers and tutorial sheets for your easy academic journey. So thank you for watching, guys. See you in the next lesson.